All right, what we are going to deal with, this is kind of the section that's at the very end of the chapter that is the flavor of what trigonometry is all about. But basically, we're going to touch on this and then we're going to stop. Because we're not teaching trigonometry, this is geometry. But it's kind of nice to see where it's going and kind of that there are further applications of trigonometry than just what we just did. What we just did was the basics. This goes beyond. And honestly, once you get into geometry, you'll start dealing with the fact that circles and triangles go hand in hand for doing a lot of work. For example, I've showed you this before. This is like a half circle. And so angles are kind of based on a circle. And so once you get into that, but we're not going to get all into that. But we are going to look at the law of sines and the law of cosines. And the purpose of the law of sines and law of cosines is it takes what we learned about right triangles and it helps us with every single kind of triangle. And of course, we already know that if you have a square or a quadrilateral, you can turn that into two triangles. And so you can actually use trigonometry on a pentagon or an octagon or any shape because we can turn them into triangles. So there's going to be two laws, and then there's going to be an area of triangles dealing with a trig. So this just gives a touch of what you can do. And so what I'm going to do is we're going to start with the area of a triangle. Of course, I'm not talking about the basic area. I'm going to be talking about the area of a triangle using just trigonometry. And we're going to use, because this section is hard, every single triangle you're going to have in this section. Well, first of all, they're not going to be right triangles, but we're going to use the letters A, B, and C. And we're not even going to try to mess with your head on this. And then the sides are going to be called A, B, A, B, and of course this one should be C. Okay, that's what we're going to do. And so the area, I'm going to have three different formulas. And the reason why I'm going to have three different formulas is because I have three different angles. And so it depends what angle you have. Trig, you're going to probably need either two sides or you're going to need an angle on a side, and then you can do everything else. With area, you're going to need a little bit more than that. But, of course, we can figure stuff out, and we'll get to that. So the area, and these are the three formulas, depending on which angle. And I bet you can figure out which angle matters. So this is going to be 1/2 B times C sine A. This one's going to be 1/2 A times C sine, what letter's missing? Sine B. This is going to be 1/2 A times B sine what? Okay. So basically, you're going to, how you pick the formula is which angle you have, right? So if you have angle C, you're going to probably pick this formula. And again, we're not going to be just super crazy with all this. We're going to look at this. So I'm going to draw a little triangle because that's my job. Okay. Whoever thought I'd have a job drawing triangles? My kindergarten teacher said I would never have a job drawing triangles, and now I do. It's amazing. All right. It's not that amazing. All right. I've wrote down all these little things here. So which formula do you think we're going to use? I have angle A, right?
The first one.
Okay, and if you need to mark stuff, this is little a, this is little b, and this is little c. So I'm going to use the first one because all you're looking at is and I'm not going to try to trick you on these, so I'm going to give you all the information you need. It's tricky as is, so you don't have to add anything to make it challenging. So I'm going to just put in this formula right here. So I'll do that. 1/2 B, 17, times C, Okay, notice how the angle's in the middle of these, right? So if someone's doing this in real life, I see your question, if someone's doing this in real life, they could measure just by standing at A. Yeah. Is this on page what?
No, is that number 135?
That's 135. That's 135. Yeah, 135. Sometimes I write it too small. That's 19, and then we do sine of 135. Okay. Is this now just calculator? It's not even algebra, is it? It's definitely a trigonometry formula, but it's just a formula. So I am going to tell you, because I told you that this chapter is all memory, right? I'm going to tell you that this section, 9.7, you see on the whiteboard where I have a formula for algebra? I'm going to put 9.7 formulas on that whiteboard. These are not memorization ones. These are ones that I don't need you to memorize, okay? That just gives you less to memorize. This is less important for memory skills. Okay, so what is my answer? What's my area?
114.2.
I got 108.1.
Well, sounds like we have...
114.2. I got 1.2.
Well, I'm going to do this and see what I get.
Yes, sir. What decimal point is it to?
I'm going to call it 114.2. And this, if we were doing area and I said that these were feet, it would be like feet squared, right?
Yeah.
All right. And again, I'm not going to make this hard. How do you pick the formula? All based on the angle. Am I going to do anything to trick you on this? No. It's just going to be area. Bam. That's the first thing. The second thing is actually called theorem 9.9, and I'm stressing it's a theorem because it can be proven. We are definitely not going to look at that proof. I did that in college. Some of these proofs can be quite complicated. You kind of have to know a little bit more mathematics than what you know at this point, which is okay, but it can be proven. So here's what this is going to be. There's two versions of these, and they're all ratios. And I'm going to show you how this works. Let's pretend I didn't do that. Sine A over A equals sine B over B equals sine C over C. So I can do it like that, or I can do it like this. And hopefully we know by now that you are allowed to flip your ratios if you want to, as long as you flip them all fairly, right? Okay, just like 1/2 equals 5/10. Is that true? Yes? Can't I flip this and go 2 over 1 equals 10 over 5? You're allowed to flip it, right? Basically, I just switch these two places and I switch these two places. So what you do doesn't matter, but you can pick one just to make your work easier on yourself. Okay, I'm going to show you what this is so we can maybe get right answers here. What we're going to be using this is to basically solve, instead of a right triangle, we're going to use this to kind of solve a triangle. All right, so I'm going to give you a little example. And again, we're going to use the same model where I'm not going to trick you. I'm just going to write some information down. And this is going to be A, B, C. And this is going to be little c. And this is going to be 11. This is going to be 20. That's good to know. And I'm going to be out of paper anyways. This is a triangle, and we're going to use this law of sines, to solve for C. Okay, basically what you're going to do, and let me scroll this, add a piece of paper to the bottom. Basically what you're going to do is you're just going to use one of these to set things up. And so what I do is I know the angle for A and I know the side of it, A, right? So for sure I'm going to use this. And usually what I do is if I'm looking for a side, I'm going to use this formula. If I'm looking for an angle, I'm going to use this formula. I'm looking for a side this time, so I'm going to use this formula. I know A, and so I'm going to write down A is something I know. So that is 20 over sine of 115. That is going to equal what is that going to equal?
Sine B over 11.
It's going to equal sine B over 11. Okay. Can't see. I need to scroll down more. So this is going to equal sine B. Uh-oh. I got all messed up here. That's going to equal sine B. Here we go. With 11 on top, right? Okay. All right. So why do we need this? I need to solve to get C. I need another angle. I need this angle really badly, right? And if I get this angle, it's going to be easy to get this angle. And then I can solve. But I can't have two variables, can I? Because then it doesn't work. Okay, so all this is cross multiplication, right? Okay, and again, I could have done different things, but I'm going to go ahead and cross multiply. So this would be 11 sine 115. And this is going to be 20 sine B. Okay, I'm going to divide both sides by 20. Okay, hopefully you are detecting this is a little more complicated than what we just did. Okay, and again, we're probably not going to master this. We're just going to touch on it, and then we'll be done with it. This is just good to see where it's going. What is next? Okay, can I put that in the calculator and get sine B? So 11 sine 115. All over 20. I just put it as a fraction. That's going to get you
0.4984.
So sine B equals, that doesn't make any sense. Surely we did something wrong, or maybe I'm not done. What is it? What am I looking for? I forgot. I'm looking for an angle, right? What do I do to that number to find the angle?
Put the converse of C. No. You put the inverse of the sine.
So put that in the calculator, see what you get. $29.9. And we're going to round to the nearest tenth. So we're going to call this B is 29.9. Find what C is. How do I find what C is? Do I have to use some complicated formula? Or can I just do 180? Well, this isn't a right triangle, remember? Minus 115.
Hi, I've seen
We're
it drop.
recording. Yep. Minus 29.9. So that gives me what? So let's go ahead and fill this in. So this is 31.1 or 35.1, right? And this is, okay. I just like to fill things in. You technically don't have to fill this in, do you? But I needed that to find this. Now I need to find this. How do I do that?
Where did we get 35.1 from?
We did 115 or 180 minus 115 minus 29.9. Okay? Not trig at all, right? All right, we're not done. These are long problems because we went from short problems, right, to long problems. Trigonometry is not a short problem kind of subject. All right, I'm going to scoot this up because I don't need it anymore. I'm going to set up the same thing, but now with C. So I'm going to still use 115 because it doesn't have a decimal in it, and I like it. And that's going to equal 35.1 over C. And I should be able to get C this way. Again, we're going to cross multiply. And in this case, I don't really have to cross multiply. I can just rotate this up here. Yeah.
Where'd you get the 35.1 from?
I did 180 minus 115 minus 29.9. Okay, let's do this here. 35.1. Okay, and I realize this takes a while because it is a complicated problem. All right. And that will get you your answer. Does that make sense? How do we know it makes sense? Big angle, 20. Smallest angle, 11. This is the medium angle, right? It should be somewhere in between 20 and 11, is it? Okay.
Would it be like that every time?
Yeah. It has to make sense. This is a real thing. And it's closer to 11 than it is to 20, right?
Yeah.
But isn't 35 closer to 29 than it is to 115?
Yeah.
Okay, so that's not an exact way to check your work, but that is a way to check your work. So I want to do the law of cosine separate. This is the main thing I want to focus on because the law of cosines gets a little more complicated. So we're going to do some work on this, and then we'll do the law of cosines later.